leveraging a lot of data already in your day-to-day. If you are someone that is, for example, I had someone that I supported in healthcare. She was essentially receiving data extracts in Excel. That's how I started out. I was getting my data extracts in Excel. That's how Kira started out, getting the data extracts in Excel. And from her end, it looks like, okay, I'm just getting these data extracts in Excel. Someone else is providing this to me. But when you take the opportunity to zoom out, you understand it like, oh, okay, that data is stored somewhere. So that data is stored in a database. And like I said, that database allows for your data to be stored in a consistent, clean manner, supposedly. Is it always like that? No. But we're going to get into that too. Databases feed into several facets. They get into that data analysis and reporting. This is that data visualization. From that Power BI to your tableaus to your anything that you had an opportunity to build a data visualization on, that data is being pulled from somewhere. Which is why I oftentimes tell people when they come and they're like, well, what should I learn? All of these tools in data work together and they all do their own thing, and it's a full ecosystem. So when you get into data visualization, which is our Power BIs, our tableaus, our lookers, any of those things, that data is being pulled from somewhere. So that back end can either be Excel or a CSV extract. It can be an API, it can be a database, but that data is being retrieved from somewhere. Another benefit of databases is that data organization and management. This is when you're getting into like your data governance, your data transformations, which is essentially I'm taking this data from one source, I'm transforming it to a useful format, and I'm putting it over here. Databases allow all of those things to happen because they keep it in that organized and structured framework. Data warehousing, data integration, quality control. Anytime you are coming in from that data governance lane and data management lane, that data stored somewhere and it's a database. Another benefit is that data sharing and collaboration. When you get your first role, your databases for your organization are typically stored and organized by team, by organization, by department. So those databases allow for you to share your data, to collaborate with your teammates, to share your analysis. Let's say, Toy, you in HR. Let's say you created an analysis that has the definition of how many people that are coming in from this department and they have this salary and they do this thing, and you did an analysis on it. And you got someone that comes in 3 months and they're like, Toya, what did we calculate here? What did we capture here? You have the ability to share your data and your analysis with whoever's asking it, so y'all can kind of make sure y'all are on the same page with whatever you trade. Same way with you, Shira, your education. Let's say you are counting the amount of students who are considered high risk from this particular region or county or district. You have the ability to collaborate with other people that have access to that database, possibly in other districts or organizations, due to the fact of this data is stored in a database. So that's the benefit of that. You're not sending stuff back and forth. We working together. Any questions on that? Yeah, I'm gonna drink my water. All right. So types of databases. So when you think of the overall type of database, the difference between databases is two things: how they store data and how they process that data. What do I mean by that? So we are learning in a relational database. We are learning in Microsoft's tool for a database. When you think of a relational database, that means that that data is stored in tables, and in rows, like in tables and in columns. So your data is actually stored in your database or on your database, which is why I provided a virtual machine to you all, because that virtual machine is essentially a laptop. And that data takes up actual space on that machine. And that data is stored in tables, and you retrieve that data. Everything goes back to data relationships. When we get into our cloud relational databases, that's where all these cloud data centers and stuff popping up. That's where all this stuff is coming from, because that data for those databases are not stored on-prem, which is like on your machine. They're actually stored in a cloud, hence the data centers. So therefore, you have the ability to, the benefit, or what organizations are saying the benefit of it is, they're only quote unquote paying for the storage that they need. They're not paying for a lot of storage that they're not using. That's those cloud databases. New SQL databases are essentially transactional. They kind of are, they only work like per session. And I'll explain that in a minute as well. Now, what the beauty of all of this is it gives you the ability, once you understand SQL and the language of SQL, you're okay. And what I mean by that is each of these databases is considered like dialects of data. Like they're considered different dialects of the coding language. All coding languages work like that. You got different dialects of Python, different dialects of everything. When you understand SQL, you might have an opportunity to where your organization might use a different type of database, but if you understand SQL, the learning curve is not going to be as deep, because they're all essentially kind of the same. And the way that I liken that to like something that you're already doing, think about like Excel. So you got Microsoft Excel, and then you turn around and you got Google Sheets. Microsoft is Excel is Microsoft, so that is Excel is Microsoft's client tool. Google's turned around and said, "Y'all got that. I'm gonna create my thing as well." So they have Google Sheets. If you know Excel, you can pretty much figure out your way how to navigate Google Sheets. It's different, but it's the same. SQL is the exact same way. I've been, like I said, 13 years, and in those spaces, I've been in Microsoft, which is what y'all are actually going to learn on. I've been in there maybe 70% of my time, maybe 80. Oracle, I've been in Amazon Redshift, Google GCP, which is considered the cloud. I'm now upskilling into Databricks, which is leaning into like the big data. And once you understand those concepts and those foundations, you okay. And what I mean by slight variations, for example, Oracle is case sensitive. So whereas you write your table name, you might have to capitalize like your table name. Microsoft don't care about stuff like that. So it's always just like little variations that you might have to do for like each client. But if you know, you know. Any questions about that? Now, let's get into retrieving data. So, when you are in SQL, or any data, it ain't even just SQL, any data tool, even Excel, when you're in data, period, it's important for you to understand the different data types. Why? Because you can't treat all the data types the same. When I am creating a table, which is what you see here, you see a create table syntax. When I'm creating a table in SQL, I'm telling the system that these are the columns that I need in my table, and these are my data types. So when I'm creating that table, I am creating parameters, or I'm defining that table to say only integers can go in this column. Only varchar data types can go in this column. Only dates can go in this column. You can't just put anything everywhere. Why? Because first of all, that's a mess. You're not gonna be able to get what you need when you need it. And secondly, you cannot treat them the same. And I'll talk to you about what I mean by that once we actually get into our code. Let's say I am trying to do a analysis and I'm trying to calculate the average of something. I'm trying to calculate the average of, I use Shira again. The average, do y'all calculate like income and stuff of certain things, Shira? We, yeah, let's let's say we're doing an analysis on the community or the population that typically attends our district. Do y'all have access to like incomes? I think they probably will when they're trying to like help. Okay, perfect. Let's say I am in a position to where it is my purpose to do an analysis to deeply understand what the demographic is that I'm serving. In order for me to do that, I have to understand race, I have to understand household demographics, I have to understand gender, age groups, let's say ages. I have to understand the age groups of those populations. If I'm doing an analysis and I'm saying, well, the average age of this is X, Y, and Z. If I try to do the average of the age column and that data that is actually in that age column is like text or varchar, it's not gonna work. Because how can it calculate varchar? How can it calculate a text? So with that, if I'm calculating something, I only have to be able to calculate an integer because that's a number. So when you're getting into those data types, it's important to say, all right, this column is only built to store this, period. Nothing else can go in there. If I try to insert any other data into this column, it's not going to work. It ain't even going to go in there. So that's why it's important to understand those different data types and how they behave and what you can actually do with those. So age or like income or any of those things to where you perform a calculation, integer all day long. It's a number. It's a numeric data type. String data type. That's our varchars and our cars. A string. A necklace. Like I have a necklace on. When I say a string of data, I'm literally talking about like a string, like the characters that is on my necklace. Or if you have like a Pandora bracelet and you have like those charms are the actual data. So that is the string. It's just a string of data. And when I define it by 50, I'm saying that it can't be any more than 50. So I'm defining the data type. Not only am I defining the data type, but I'm defining the length as well. Date time, that is what it says it is. It only can house that date time data. And if you are someone, I keep going back to like Excel, but if you're someone that's already heavily using data, already heavily using Excel, you already heavily using those things, you're leveraging data types already, because even if you have to do certain analysis in Excel, you got to be aware of it. Do you need to memorize these? No, don't even try to. But at least be aware, and as you do your data investigation, to go and look at your data and be like, okay, well, it's an integer. Okay, well, it's a varchar. Okay, well, it's a date time, and which we will get into data investigation as well. But as you start doing those things, start training your brain to start looking at some of this stuff. Do you need to memorize? Don't even try to. Don't even try to, but at least know. Any questions on this? Okay, don't play with y'all. Now, let's get into our database. So, for y'all, y'all should already be connected to the VM. And if, connect to your VM, and let's go. Let me know once you connected. It came from me. And then Shira. Okay, Kara said she typed in SQL username. Shira, your VM for Excel is the same one for SQL. Are you using the same laptop? Oh, okay. I was going to say if you're using the same laptop. Oh, Kira, you are so helpful. I'm gonna see if I can find it and forward it to you. Okay, I'm forwarding it to you. Okay. Toya, you good? Okay. Kira, you good? Monica, you good? Okay. So I'm gonna share my screen. Well, I'm still sharing my screen. Oh, I was pulling up my database. So I'm gonna show y'all how it look once you get over there. When you okay. When you log into your VM, look for this icon on your desktop. The yellow block with the green and the blue, and double click on it, and it should open up for Microsoft SQL Server Management Studio. Shira, let me know if you got any questions. And you know what? I'm thinking through this today. Our first use case is actually education. You gonna eat? Okay, there we go. All right. So when you open it up, it's gonna ask you. Let me go back. Well, it's gonna ask you to like connect. So click connect. And if you want to share your screen, and something else pop up, just do it, and we'll make sure you are good. It should be just like this. And then who is that? Shira. Okay, okay, okay. Just click connect. Now, what you're doing now is you're connecting to the database. Click connect, and it's gonna push you on through. If it asks you if you want to save the code, say no, because y'all write y'all own code. And let me know. Let me see, Kira. Did anybody else? Okay, let me stop. Oh, do not recover. So keep your screen up, Kira. If you get this, say do not recover. So what it's asking is if she wants to save any of that code that was already on there. But y'all go write your own code. Yep. So you click do not recover. Now there you go. Now click connect. There you go. Now she's connected to the database. All right. Now your screen should look like mine. And if it don't, raise your hand. All right, so let's walk through this. Now, remember how I was saying that you have different types of databases. Regardless of the type of database, if it's Oracle, if it's Amazon Redshift, if it's Microsoft SQL Server, they're essentially all pretty much laid out the same way. So get familiar with the layout, with the structure of everything. And every session when we go through this, I always walk through it because like it's important for your brain to kind of start thinking through that lens, especially with us going deeper into data. So what you see right here, this is your server. So when you think about back in the day when we had computers, like big computers, and it had like that big CPU. This is the CPU. The server is everything. When you navigate in this space, you will have probably different servers, but they all pretty much will just line up just like this. They'll all just be lined up in the black boxes just like that. It's not uncommon for your server to also be called an environment. You might have your production environment. That's live data. That's what HR is using. That's what they're making informed decisions on. That's where your financial data, like HR is live. Like we live, baby. So you might have like your production environment. You might have what is called like a dev or QA environment. Those are like your testing environment. Let's say you are working on a big analysis or project and you don't want to touch production data, which you should not. You'll just do it in a different environment. Oh, Toya, you know, now I'm thinking through this. This might be similar to like your data migration project. Okay. Okay. I was thinking it like as soon as I said it and I looked down, I saw your head like going like that. But those lower environments, like your devs, your QAs, they're not connected to their production data. Their production data is what shows up for the public, and it's the real deal stuff. They all are laid out the same, they all look the same, but when you get in your space, you might be limited sometimes by not dibbling in actual production data. It's supposed to be protected, basically. Is it always protected? No. Is it supposed to be? Yes. So, server. They all the same, everything. Now, after your server, click on your databases and extend your arrow for your database, your drop down. I have more databases than you all show up on your side, but it's all good. You're not missing nothing. So extend your databases. Now, we opened up this session with what is a database? And what I say, anything that stores data, period. As we navigate through these sessions, there are times, we actually gonna do this in session 1, to where you'll be applying changes to the database, testing your change. You'll be working back and forth as if you are like a data professional today. These are your databases. Databases store like data. It's organized. You have your security parameters on it. Everybody in every part of the organization might not have access to it, or might not have certain permission to certain data, or might not can even do everything up in here. They're not supposed to, because the data is supposed to be protected. These are your databases, these little black boxes. Now, as I was saying, you have your different dialects of SQL. You got your Oracles, you got your GCPs, you got your Amazon Redshifts, you got all these different types of databases, and they're all pretty much kind of like this. So these black boxes are your databases. For today's session, let's go into our Data Analytics Simplified database. Let's expand it. So you can press your little arrow right there and it expanded. So you got your server, that's the big dog. You got your databases, very much so still the big dog. Then we getting down even more granular into our tables. In a relational database, your data is stored in a table. Expand your tables. Press the same arrow and it'll expand your tables just like that. Your data is stored in tables. So these little grid things here, these represent tables. These are your tables. Server, database, tables. Now, let's take a look at the data that's in our table. We can do that multiple ways. The first way is, what we're going to start out doing is data investigation. Go literally investigate your data. So let's start out with our courses table. Expand it, and let's expand our columns. So do your 2 drop downs. You got your table and you got your columns. So you got your server, you got your databases, you got your tables, and then you got your columns. Now we're looking at this, we see, we can make sense to be like, okay, this must be the column name. This must be, we can look at this and say, all right, I can tell what type of data stored in here. You see your column names, but you also see what is this? Yes. Yeah. What is that? Data types. But yeah, these are data types. And it is a string. Come through, Monica. That's exactly what it is. It's our data types. And with that bar chart, it's a string. So we have our data types, we have our tables defined here to where we can look at this and we can say, all right, this is a string. Not only do we see our data type, this is an integer, so we know, all right, this has to be a number. We see this varchar, we see it defined. Now, another thing we see here is the PK. Does anybody have any idea on what PK possibly means? Primary key. That is our primary key. I'm typing in the chat. That primary key is my unique identifier for that table. Basically, no 2 primary keys can be the same. This primary key gives me the ability to look at that column and say, all right, this can't be a duplicate. This is how I'm able to tell this column from this column because of this primary key. Let's go down here to our enrollments table and let's do some more data investigation. In this enrollments table, we have 5 columns. We have our enrollment ID, our student ID, our course ID, our enrollment date, and our grade. Like Monica was saying a minute ago, these are our data types. Our tables are already defined. We have, out of this enrollment table, which field or which column is our primary key? Yep. Then you scroll down, not even scroll down, but you go down just a little bit further, and you see you got your course ID, and you have an FK. Does anyone know what that is? It's your foreign key. When you think of something, a foreign object, a foreign card, a foreign whatever, it is indicative that whatever you're referring to is not from there. It ain't. It's from somewhere else. In data, it's the exact same way. I have my primary keys, which is my unique identifier for that table. This is how I'm able to tell each of these records. Their primary key gonna tell me. Then I turn around in this other table, I see I have my primary key, cool. But I also have a foreign key. So that foreign key is the unique identifier from another table. It's a foreign, it's not from there. So when I'm looking at my enrollments table, and I see that in my enrollments table, my course ID is my foreign key, what other table has a course ID? Our course table. Now the course ID. Yep. What other table has the course ID, Monica? Besides the enrollments table. Yeah, you do. Because you just said it a minute ago. It's this one. It's this one. If we look at our course table, we have our course ID right here. But in our course table, it's our primary key. Then, yeah. Then we come down here right here to our enrollments table. In our enrollments table, we have a course ID too, but it's a foreign key in our enrollments table. This is at its core a data relationship. How are these two tables related? These two tables are related by the course ID. In life, I'm a person, I have a cousin. We're related. How are we related? Our parents. Data's the same way. These are the parents, these are the cousins. Yes, it's sharing the same, it has the same column. I'm telling you, when these tables were defined under the part that this course ID in this table is the primary key. That's my unique identifier. I cannot have more than one. Primary, primary, primary. I turn around and I have this enrollment table. I have my course ID here, but of course here is a foreign key. Therefore, my enrollment table is related to my courses table on that course ID. That's the data relationship. These two, your data, and I'm pushing this early because in session 3 we do joins. And joins are driven by data relationships. And if you start training your brain to kind of look at your data from that granular detail and say, all right, this is my data relationship, it's going to help you be able to join those tables. Because let's say I need data from this table and then I need data from that table. I can't just randomly pull that data. I got to join that data on something. And it's going to be that data relationship. Also, as you start to navigate the space, and if you are having to like go through a tech session or whatever the case is, it's important for you to understand that data relationship, even if you are in the position to where you want to, let's say you want to start like consulting or doing data analysis on your own. and you have all this data, it's important for you to be able to keep your data quality up by saying, all right, if I'm joining these two data sets, I'm joining these data sets on this primary key and this foreign key. So that's at its core a data relationship. How is this table related to this table? On what though? On my course ID. This is my primary key, this is my foreign key. And that's also a common question in interviews too. What's a primary key? What's a foreign key? Because it drives so much data analysis. It drives so much initiative with the goal of what? Having clean quality data. So that's why I started like session one. Go look at your data and start getting like your brain familiar with them data relationships. Same thing in our students table. Our students table, we have our primary key here, and it's gonna relate to this student ID in our enrollments table. But you notice that this student ID is not defined as a foreign key. It's fine. It can still relate. You have to have you got to get that primary key though. You have to have that primary key because that primary key is what makes each record unique. So you don't have two duplicate or dupes in your data set, which falls into like your data plans and stuff like that. But this database has three different tables: courses, enrollments, and students. And every time you about to do an analysis, nobody is gonna come to you and they're not gonna say, hey Lorita, um, can you retrieve these records from this table and this? They gonna come in and say, how many students got a B last year? Or how many people did this last year? How many people did that? So it's your job to kind of get familiar with like doing your data investigation and stuff. So every time when I ask questions, kind of go over here and extend your columns so you can say, okay, well this table has this data and work from there. Any questions on those data relationships? Okay. Let's retrieve our data. So let's right click our students table and select our top 1,000 rows. Just right click it and then your select top 1,000. Feel like this, Monica. Right click it and then select top 1,000. Let me see. Yeah. I'm gonna stop sharing. Make sure it's to get with your code though. I don't want to see your credit card in there. Yeah, I do entire screen. I had to go back and look and make sure I was not doing one. Oh, you probably got some kind of permissions on there. What is it showing, Monica? Are you right clicking? Students. Let's go to our students table. Yep. Are you getting this at all? Only click on the table, like click on this part right here with the little Excel looking thing. Click on it, like right click it and then click select top 1000. Okay, because I want you to do it. I want you to be able to do it too because I think you're doing real good and you saying you ain't nothing. You doing real good. Click, send me a screenshot then, Monica. What you do? Um, yep, it'll do it. So right click and then click select top 1000. Don't, hold on, we don't apologize here. So you know, we learning, we learning. So you straight now though. Okay. Now, what does this look like? Do this look like an Excel extract to you? Mm-hmm. This down here is called an output. This is your output. Now up here, this shows up exactly what we told it to. We right clicked and selected our top 1000 records. Really, Kira? Nobody? Okay. That's crazy because ain't nobody else here. Um, but I go look. Yeah, Kira, but that's crazy. Um, you got your top 1000 records. Now here, you notice that select top from all of these are blue. Those are called reserved words. Those are called reserved words. It's no different than when you are in Excel or when you are in any other coding language. Your code gonna be different colors because it is with the expectation of this does something. So here we have our select top 1000. This top 1000 is called a limit. This limits the amount of records that we have in our output. This is the output. And if you see down here, it's showing up exactly 1,000 records. If I wanted to say top 100, it's going to give me 100 records. Whatever I put in there, it's going to give me that. If I wanted to say top 10. So if you get a question like, what's the top 10 salaries from Toya HR? What's the top 10 salaries from this department? All right. So this is the limit. So here we have select. In SQL, all of your data is stored in tables. All of our data is stored in tables. When we are retrieving our data, which is what we're doing now, we have to select these columns from this table. Think about it like this. When you go to a grocery store and I have like all of my produce on this shelf and I want this and I want that and I want this. That's how SQL works at its core. I'm selecting columns from my table all day long. That is baseline what you're doing in SQL. Let's first start out here and let's get rid of our limit. Let's get rid of our top 100 or whatever you had. Delete it and then execute your data again. Kira, try again in a minute. I don't know why it's doing it to you because I want you to be able to do what you need to do. Um, so here, select our columns from our table. Let's say I don't need the student ID in my output anymore. I only need the first name, last name, enrollment year, and major. Best practice is don't delete student ID. Don't ever delete your columns. Why? Because you might have to go back and use it, and it's easier just to keep it in there and get rid of it as you need it. Comment it out. So do your two dashes, and it'll comment it out just like that, like it doesn't even exist. And you see your comma. Well, if we execute it, it's gonna give you an error. It's gonna say incorrect syntax near this comma, because this comma just basically hanging out there. Just delete your comma and then re-execute. And you notice it's gonna change your output. You have 100% control over what shows up in your output. What you need, if you need something, put it up there. Put it in your select statement. I have to select my data from my table. Whatever I have in my select statement is going to show up in my output. And vice versa. If I don't have it, it's not going to show up. Best practice, don't delete, just comment out your code on whatever you don't need. Another thing you'll notice that's different kind of than like how we naturally work is the commas in the front. The commas are going to be in the front of your columns. Keep them in the front. Keep them in the front. Don't go and like try to switch it up or anything like that. And the reason being is because let's say I want to add this column back. I just add it back and I don't have to go through and try to go add my columns again and do all that. Just keep everything in the front because it makes it easier for you as you retrieve your data. So we have our select these columns from this table. Now, you see this is broken down in 3 different pieces. This is our database. You see a master database. This is called a schema. A schema is essentially how the tables are organized in a database. When it has that DBO in there, that is how Microsoft and any other tool really naturally gives a schema. But you can change your schema to anything you want. Let's say you are working on a certain project and you want all of your tables that is responsible for that project all grouped together. You can change your schema to that project name just to keep your data organized even in your database. It doesn't break anything. It's not going to do anything, but it just helps you stay organized. And this is your table, students. So when we are pulling data, you always pulling data from a table because that data got to be stored somewhere, and it's a table. Any questions on selecting that data? Let me see. I love it. Let's debug. Yep. And make sure you share your code. That's crazy. I'm gonna reset your password today because I don't know why. Okay, there we go. All right. All right. Does anybody else see the problem with her code? Why is she getting that syntax error? Yep. Delete that top. You just need your select. Another head. Yep. Not execute. Perfect. That's exactly what it is. All right. Got your okay, so the reason why they gave you this, when you say top, that top is considered a limit. So what SQL was doing was it was expecting for you to come through and say top what though? Top 10, top 5, top 20. What you trying to do? So that's why you got your area. Good job, Monica. So you got your select statement. Now, let's say I only needed students who enrolled in the year of 2023. What column would I need to answer that question? Come through. Let's get into filtering our data. So if I say I only need students who enrolled in the year of 2023, enrollment year is the column that I would use to filter that data. But for me to filter, I would have to say where. Where what though? Where this column, you don't have to do the brackets. I just do it sometimes. Sometimes I don't. But where this column equals this value. Execute. This allows you to filter your data. And when I say filter my data, think of a literal like coffee filter. That's how my brain formalizes it. I have a coffee filter. I have my coffee that is in a, I put my coffee in the filter. Nothing shows up in the coffee pot other than what I need. Same with my data. I'm selecting these columns from this table where this column equals this value. Nothing shows up in my output but students or records, rather, that meets this criteria. Nothing else shows up over there. If I wanted to say, where I want a list of biology students, I wouldn't use my enrollment year. I would use my major, where major equals whatever your characters are. Now, this is where we are going to get into data types as well, because you see, this is gonna, if I say where this column equals this value, it's gonna throw me an error. And the reason being is because when I look at my major data type, it's a varchar. It's a string. So if I'm doing a string, I have to put my single quotes around it. Integer, I don't have to do that. Enrollment year was an integer. I don't have to do that. But for strings, I got to put them single quotes around because of the data type. So this where is a filter. It's a filter, it's a condition. I only want records that meet this criteria. I only want records that meet this condition. I only want records that meet whatever I'm defining it to be. And you notice that when we filter our data, we filtering our data based on what though? Based on them fields, based on your columns. Any question about filtering our data? Okay. The first use case, the first use case is, and I'm gonna type it in the chat. I need a list of all students who made a B. So I'm gonna type it in the chat, and I want you to go and do some data investigation to do what? First of all, figure out which table you need to use. Really? Oh, you to the VM, Shira, or to this? Really? What is it saying? And it's saying what? being hacked. Hold on. Toya, you good? Monica, you good? Yeah, it is. I see yours. Are you are you using no I'm saying are you using your new one, Kira? Because I'm now that I'm thinking through this. Okay. I think you and Shira might be knocking each other off, man. If you and Shira, did you just connect? Okay. That's it then. I'm like, hold on, y'all scared. Okay. Make sure you make sure, let me see. So Kira, okay, let me see. Yep. All right, Kira. Let me get you a new one, Kira. Hang tight. I'm sending it over right now. I'm sending you over some credentials. That's it, y'all. I was scared. I'm like, what is this? Yes. Let me pull it up. Let me see yours, Kira. All right, so y'all, we should be good now. Yeah, that's what it was. It was connecting to like all right, Kira. Let me make sure you're not on here with nobody else. Okay, I got Kira, Monica, Shira. Okay, good. Toya. All right, Kira. Yours is gonna be a different one. Okay, okay, okay. Oh wait, Toya, which one are you connected to? Let me go. I can go look. Okay, we good. We good. Okay. Perfect. All right, we good. Yeah, we should be straight now. All right. So if you see, y'all scared me. I'm like, why? All right. If you see, we're filtering our data. So we're essentially saying, I only want records that meet this condition. I only want students who meet the condition who are in biology, period. Now, for the first use case, I'm going to give you, I need a list of students who made the grade of a B. Now, first things first, I need for you to do your data investigation. Which table answers that question? Come through, right click on that table and select your top 1,000 rows. Now, I only want a list of students who have a grade of a B. So first things first, we need to get rid of our top 1,000 because our top 1,000 is a limit. So it's going to limit the amount of records that's showing up in our output. We don't want to limit our data. We need our data. So get rid of your top 1,000 and write your code to enter which students made a B. Toya already identified the table. Now we need to filter our data. I'm gonna put this up so you can see it. We need to filter our data to only pull students with the grade of a B. That scared me. Were y'all able to get, or do y'all want to talk through it? Do they give them? Okay, this equals, and then whatever value you doing, make sure that it actually matches the value that's actually in that table. Toya, what were you saying? Yes. Yep. So when you say where, this is your filter. You starting out your filter right then and there. You put your filter in your coffee pot. That's the equivalent of it. Where this column equals this value. And make sure your value matches whatever down there. If it don't have to be like, I don't mean like uppercase, lowercase. But I mean like as we get deeper into the session, you might feel like something might be written this way when it actually is written this way. So just make it a habit to like actually look at your data. But I'm getting all these records from this table where this column equals this value. Shira, did you good? Okay. You want to walk through it with us? Go. Yeah, share your screen, Kira. You should be. Oh, I like her, especially lately. All right. All right. Okay, that's it. We in our enrollments table, Kira. So right click your enrollments table and select your top 1,000 rows. Yeah, no, I don't know nothing about no Mac, Kira. I think who else got a Mac? You gotta right click it though. Yeah, you gotta. If you right click it and then click select top 1,000, it'll take you to the. Okay. Yeah. Cause they them Macs a little. My husband got one, and I can't. Yeah, I can't. I be like, I can't do this. Get this away from me. Um, but he got the not he. We got the columns, and we are able to filter our data. So this allows this output to only reflect what we actually need. So okay. Any questions on this? Okay. Oh, let me see. Oh, you talking about like this up here at the top? Okay, you straight. Okay, yeah. You good, you good. Yeah. Sometimes it auto populates it and sometimes it doesn't. And I'm actually want to talk to y'all about this anyway. So you see up here where it's green. It's green because of it's commented out. So we talked about one way to comment out. What'd you say, Shira? Okay. We talked about one way to comment out one line of code, which is our two dashes. But let's say we want to comment out a full block of code. You put your backslash star and then your star backslash. And anything that's in between those is going to be commented out. So it's not going to affect anything. And I wanted to talk to y'all about that because the next use case we go through is gonna require for you to comment out your code. You're gonna be writing your code, comment it out, testing it, like you're gonna go back and forth, back and forth. But there's two ways to comment out your code. One way is two dash. Let's say I only need one line gone. Perfect. Two dashes works. But let's say I need a full block of code gone. I need to use that start backslash, and that's what's going on up here. One works just like how it is in the chat, Toya. That what backslash star and anything that's in between there is like not even gonna show up. It's gonna be green like that. Any question about filtering your data or conditions? All right. So let's go into our next part that is gonna lean on it as well. So select. We got our select here. We are selecting this data from this table. The next phase of DML languages is insert. I need the ability to insert data into a table. It sounds exactly like what it is. Insert into your table name, the columns that you're trying to insert that data into, and the actual values that you're inserting into those columns. So it's table, columns, values. That adds new data into the database. Now, for this use case, I need you to insert, you need to go back to your student table because you're about to insert yourself. And I actually have this pulled up so you can see it while you do it. But you need to go back to your student table. If you want to use the same tab you already had, that's cool. Or if you want to create a new tab, select your top 1,000 rows. Either way is cool. Go back to your student table because for this use case, I need for you to insert yourself as a student in a student table. Make your student ID 80,000 and you can make your major anything. So insert yourself as a student in a student table. And if you wanted to use the existing code, like the existing tab, you can. Make sure though that you comment it out. So if you're using that one, be a backslash star and then star backslash, and it's like it never existed, and you write your insert syntax right here. And I'm gonna move so y'all can see it. But insert yourself as a student in the student table. Oh, and another thing, when you're inserting into, like for this syntax, insert into table name, just copy your full table name. Don't try to like rewrite all that because you might get a space or, something like that and just confuse yourself. But just copy and paste it directly. And let's insert yourself as a student in the student table. So insert into, you go into the student table, so to be your student information here. Open up your parentheses and list out every last one of them columns. Then you come right down here. Now we get into our values. What data do you want in those columns though? This data. And you can make your major anything you want. So insert yourself as a student in the student table. And make sure you comment out your code at the top because insert and select, they can't function at the same time. You're going to get an error. So make sure you comment out. Who is that? Monica. Who is that? Because I had my screen down. Girl, you talking about you don't know. You started out saying you don't know. You be coming in strong the whole session. You're doing really good. Mhm. Comment it out. No, put your backslash star. You see how I got my right here? Backslash star. Put that right on the top. And then come right here and put it star backslash at the bottom. And it's like a sandwich. Like anything that's in between there, it's not gonna show up. Oh yeah, for sure. Yeah, for sure.